Hello, am I audible?
Yes,
Yes,
ma'am.
yes, ma'am.
Uh, okay. So, welcome to the first session of Maths 1 for Electronics. In this session, we will cover the first few topics from week 1. So, our focus will be toward the theoretical side of whatever content we have covered in week 1. So, these are the topics we will cover in an hour. First is number system, then mathematical approach for problem solving. So this means that if you have some question is given to you, and that question few quantities are unknown for us, and some relation is given in between these few quantities. So what we have to do, we have to create an equation using that information, and then try to solve it or try to guess what will be the values of those unknown quantities. And after that, we will go through the very basic definition of a function. That initially what is a function is, and then we try to see what is a graph of a function means, and then we will cover straight lines, straight line equations, straight lines, what are the various conditions, and how we can represent a straight line, and all those things. So these are the topics I want to cover. Is there any doubt, anything you guys want to ask before starting the session? Yes, Ankit.
Hello, good morning, ma'am.
Yeah, very good morning.
Ma'am, ma'am.
Yeah, you're audible, you can say. Hello, Ankit. Okay. Anyone else has any comment or any doubt? Okay, so let's wait for 5 more minutes and then we'll start our session so that other people could join. So the attendance criteria is overall, I think you have 35 sessions. So from that session, you have to attend some minimum number of sessions. So I don't remember what is the minimum number is that. I think it's 30 or 32 something. So if you are unable to attend those many sessions, then you have to give a valid reason. Otherwise, you won't be able to attend the exam or something like that. Is there?
So, ma'am, how the attendance will be taken?
I think it will be taken via the Google Meet itself. So there is one feature in Google Meet that it will record whatever the participant is there in this meet.
Okay, okay, thank you.
So I think by your attendance in Google Meet. So that's how we will record how many sessions you guys will take. So in qualifier exam, there will be 4 weeks content is asked. So in those 4 weeks, there are 4 graded assignments, right? So from those 4 graded assignment, if you submit at least two, I mean you have to submit at least 2 graded assignment to be qualified to sit in the qualifier exam. So that's the meaning of this message, that you have to submit at least 2 grading assignment from 4 weeks. I mean, there are 4 weeks. So from those 4 weeks, you have to submit at least 2 graded assignments.
Okay, thank you, ma'am.
But submitting all assignments are necessary for a higher mark, right?
Yeah, that's correct. Because when your final score is calculated, then I mean, there is some weightage is given to grading a graded assignment. So it's if you want to score higher, you have to submit all the graded assignments.
Thank you.
Okay, so let's start. Still people are joining, so let's see. Okay, so let's start because it's an hour session. So we'll start with the number system. So in between, if you guys have any doubt, either you can raise your hands or you can just unmute yourself and ask me. Yeah, so the main purpose of this first session is just to introduce these 4 topics in detail. So in our week 1, we have covered these topics as well as the quadratic functions. So in the next session, we will see quadratic function, what is a quadratic function, and try to solve some of the good questions regarding to these topics. Okay, and in the next session, we'll take the doubts on practice assignment, activity questions, and whatever other doubts you guys have. So that session will be will completely devoted to that particular thing, that solving the doubts. Okay. So let's start. So first we'll start with the number system. Okay. So in mathematics, we have several numbers. So we'll start with the basic number system. So that means the natural numbers. So what is a natural number? So natural number means the natural way to count something. So for example, over a table, if you have some number of books, then how will you quantify those numbers? So whatever number we use for counting naturally, those are known to be the natural numbers. So in some cases, some people involve zero in natural number and some people does not involve in zero in natural number, and they categorize into 2 parts, the whole numbers and the natural numbers. So we just stick with some basic notations. So this n is actually denoted, this n actually denote the set of natural numbers. So I think you guys are familiar with sets. So set is nothing but a well-defined collection of objects. And in this set, you cannot repeat an element. So this symbol, this capital N, is actually denote the set of natural numbers. So what is the set of natural number is? You just collect all those natural numbers, that means 1, 2, 3, 4, and so on. So this is known to be a set of natural number. And this is a general way to write any set. So use curly brackets to enclose the elements. And this n specifically used for denoting the set of natural numbers. Okay. So this is the set of natural numbers. Okay, so now we have several operations over the numbers. So that means we can add 2 numbers, we can subtract 2 numbers, we can multiply and divide. So using these operations, so that means if we apply these operation over the natural number, then what will be the result we obtain? So over this concept, we develop our number system further. So for example, if you add 2 natural numbers, so for example, if I add 3 plus 4, then it will again give me a natural number. Right? This is again a natural number. So that means it belongs to set of natural number. But what happens if we subtract two natural numbers? So in some scenarios, it will give us a natural number, but in some scenarios, it won't. So for example, if we subtract 3 from 4, then we will get 1. But if we reverse this order, so that means if we subtract, if we do 3 minus 4, then we will get minus 1. And this is not a natural number. Right. So that means physically what we are saying. So physically we are saying that in a basket we have 4 apples. In a basket if we have 3 apples, then we cannot pull out 4 apples. We don't get any natural quantity or natural thing with happen. So in this scenario we are getting something which is not a natural number. So we uses this negative sign and these natural number to construct a new number system or the new set of numbers, and those numbers are known to be the integers. So integers are nothing but numbers which we can obtain by subtracting two natural numbers, you can say. So the set of integers is denoted by this particular z. This is used to denote set of integers. Okay, so what is a set of integers? So set of integer is nothing but those numbers, all natural numbers involving negative natural numbers too. So negative natural numbers means minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Okay, so we have some ambiguity about 0. So some people involve 0 in natural numbers, some people won't, and they call it the whole numbers and all those things. Okay, so now as we use a subtraction to develop the set of integers, now we will use division to develop the set of rational numbers. Okay, so for example, if we divide 4 by 2, so for example, if we divide 4 by 2, 4 is a natural number, 2 is a natural number, and if you divide 4 by 2, you will again get a natural number. But this is not the case in with every natural number. So for example, if you divide 4 with 3, this is not a natural number, right? So what is this number is? So we again try to enlarge our set of numbers, and we say such type of number are known to be the rational numbers. So there is a precise definition for rational numbers. So what is the rational number? So a rational number is a number of the form p by q, right? So it is of the form p by q. We always use this type of form where there are certain restriction over p and q. So what is the restriction? That p and q both are integers. Right? So you can take p to be minus 1, q to be 1, or anything you can take. But the restriction is p and q both should be integer, and this q should not be equal to 0. Okay, we cannot take q to be equal to 0 because it doesn't make sense to divide a number by 0. We will get so many results. So that's why division by 0 does not make sense. So a rational number is nothing but a number of the form p by q, where both numbers p and q are belong from the integers, and q is not equals to 0. So these are known to be the rational number. And the set of rational number, please mute yourself. Okay. And the set of rational number is denoted by q. Okay, so this is the notation for denoting set of rational numbers, q, with this particular line. Okay, so let's recall. So what is the set of natural number? So set of natural number is 1, 2, 3, 4, and so on. Set of integers is minus 2, minus 1, 0, 1, 2, and so on. Okay, and set of rational number is all the numbers of the form p by q, where our p and q both are integers, and q is not equals to 0. Those numbers are known to be the rational numbers. Now, what happened when someone developed this number system? We came across to a very well-known result, which is known to be a Pythagoras theorem, right? So, what does Pythagoras theorem says? That if you have a right angle triangle, then the length of hypotenuse is nothing but the square root of squares of these two lengths. So that means if I denote this length to be a, this length to be b, this length to be c, then by Pythagoras theorem we easily know that a square is nothing but b square plus c square. Right? This is a well-known result. You guys have seen it in your 10th or 12th standards, right? So it's a very basic result, and it is true. We know that it's actually true. So what happened if we take the value of b and c to be equal to 1? Okay, so if we take b is equals to c is equals to 1, then what is the possibility of A? What is the A? So this is same as saying that A is nothing but the square root of B square plus C square. Okay. In general, when we go from square to square root, we will take plus and minus sign. But since here we are talking about the length, and length cannot be negative, so that's why we are taking the plus square root. Okay. So now what happen if we take B is equals to C is equals to 1? Because we can construct a triangle with sides with the length of side is actually equal to 1, right? So if we consider this triangle, this right angle triangle, whose two sides have length equal to 1, then what will be the length of this particular hypotenuse? That's our question. So by Pythagoras theorem, it simply says that A should be equal to under the root of 1 square plus 1 square, right? Which is nothing but A should be equal to something under the root of 2, right? So but what happened here, this under the root of 2 is not of the form P by Q. It is not equal to some P by Q, where P and Q are integers. So that means this is something new to us if we are talking about number system. So far we learn about natural numbers, integers, rational numbers, but this root 2 is something new to us, which is not which is neither a natural number nor an integer nor a rational number, right? It is not of the form P by Q, but it is something real. So right, because this length is actually real, we can construct a triangle with this particular length of root 2. So what we call such a number, so such a number is known to be irrational numbers. So this root 2 is known to be an irrational number. Okay, so such kind of square roots, root 2, root 5, root 3, and so on, root 11, those numbers are known to be irrational numbers. Okay, so here we get one more set of numbers. Those are known to be an irrational numbers. So now here, one thing I want to make a note. So what do you guys think? 0 is a rational or irrational? 0 is an irrational number or a rational number? What would be your answer?
Ma'am, 0 by any number is 0, so it should be a rational number.
Correct. It should be a rational number because we can write 0 in terms of P by Q. So if you can write any number in terms of P by Q, where P and Q both are integers and Q is not equals to 0, that number is a rational number. So you can simply write 0 to be equal to 0 by 1, right? It is of the form P by Q, where P and Q both are integers. So that's why 0 is a rational number. So never confuse with 0 that 0 is irrational or rational. 0 is a rational number. So now what happened? Now we have four type of numbers. We have natural numbers, integers, rational, and irrational. So now what we do, we just combine all those numbers and form a new number and enlarge our set. And that set is known to be the set of real numbers. So what is the set of real numbers? So real number is nothing but rational numbers combined with irrational numbers. Okay, and the set of irrational number is denoted by Q with this upper script of C. If you guys are familiar with set theory, it is actually denote for complement of a set. Okay, but this is a notation. This is a notation for irrational number. Okay. So real numbers is nothing but rational number union with irrational number. Union means you just have to take all those numbers together. So it means rationals and irrational combine will form a set of real numbers. Okay. Now after real number, we come across a new number system. Those are known to be a complex number. But complex number we will study in week 11. Okay. So complex numbers. So complex number is fully covered in week 11. So initially, I'll just give you motivation. So why we come across two complex number. So what happened? We have some equations, and we want to solve those equations. Solve those equations means we want to find the value of x which satisfy those particular equation. So if we have this type of equation that x square plus 1 is equals to 0, and here if you want to find an x which satisfy this equation, satisfy this particular equation, then this x square should be equal to minus 1. But then x cannot be a real number. Why it cannot be a real number? Again, the real number set is denoted by this particular r. Okay, so we have a fixed notation for each set. Set of natural number, we have that n. Set of integers, we have z. Set of rational, we have q. Set of irrational, we have q to the power c. And set of real numbers, we have this particular r. Okay, so it turns out that any real number cannot satisfy this particular equation. Why it cannot satisfy? Because here we are saying that square of a quantity is equal to -1. But we know if we take any real number and if we square it, it will become a positive. It cannot be negative, right? So because of that logic, we can say that there is no real number which can satisfy this particular equation. So with regard to this problem, we enlarge our set of real number, and we define some numbers which are known to be complex number. So in complex number, we can find a number which actually satisfy this particular equation, and that number is nothing but known to be iota. Okay, so I think you guys are familiar with iota a little bit, but we will see complex number in detail in week 11 with all the properties of iota and polar whatever other things are there with regard to complex numbers. Okay, so this is our system of number system, we can say. Okay, so is there any doubt so far? Any comments?
No.
Okay, so let's move ahead. Now, the next topic is mathematical approach for problem solving. So in this topic, what you have to do, some question is given to you, and in that question, some unknown quantities are there. So what some unknown quantities are there, and there are some relation with respect to those unknown quantities. So what we have to do, we have to define an equation which will capture the essence of that particular relations, and using those equation, we try to find out the unknown quantities. Okay, so this is the method we will apply. So first thing, we will identify the numerical quantities in the problem. So whatever the known quantities to us, those quantities first we will try to understand what are those quantities, and then what we do, we will assign some variable to unknown quantities. So here, what does this term variable means? Variable means it is a quantity which can vary regarding to the situation. So for example, if I write that's why the variables are denoted by the small alphabets x, y, z. So these three symbols x, y, z we oftenly use to show a variable. So variable means it will vary according to your situation. So for example, if I give you two situations, so for example, I'll say that 2x plus 14 is equals to 0. And if I say that 2x plus 12 is equals to 0. So in this scenario, if you calculate the value of x, it will be equal to 2x is equals to minus 14. So x is equals to minus 7. Okay, and in this scenario, if you calculate the value of x, then 2x is equals to minus 12 and x is equals to 6. So what is happening here? The value of x is equals to minus 7. Here the value of x is equals to 6. So such kind of quantities in
In
maths,
second
we
part,
talk
x
about
is equal to
variables.
-6.
Sorry, what?
-6, ma'am. It should be -6.
Yeah,
-6.
minus 6. Yeah. Fine. So such kind of terms or quantities in mathematics are known to be variables. So that means those will vary according to your situations. So what we do in a question, we try to find out variables or quantities which are unknown to us. And for those quantities, we will assign some variable x, y, z. Okay, then what we do in the third step, we will try to find out the relation between these two quantities. That means whatever the known information or the known quantities to us, and what are the unknown quantities to us, and what are the relation in between them, and then try to solve this those particular equations, right? And then form the equations and solve it. Now what happened, these type of equation can get more complex according to your situation, but since we are in the initial step, we will just tackle with the linear equations. So what are the linear equation? Those things we will see in few minutes, but first try to solve one basic question. So this is a question we have. So I'll give you guys 5 minutes to solve this question and answer in the chat. Okay, so I'll paste it over here. Okay, the question is clearly visible, right?
Yes, ma'am.
Right. So what you have to do, you have to go step by step. First, understand the known quantity, understand the unknown quantity, assign the variable, form the equations, and then try to solve it. So I'll give you 6 minutes to solve this question. Yeah, this question can have multiple answers. So it depends on, let's see. Such type of questions can have multiple type of answers.
Ma'am, but the question mentions that there should be an 8 kg of flour. So
Yeah. So because of the 8 kg, I think it's unique. 8 and 0 maybe. Let's see. Yeah, because of the 8 kg, we have then two equations. So two equations, two variables should be unique solution. Such kind of thing you will learn in week 2. That if you have two equations, two variables, then it will be a unique solution or no solution type of thing. System of linear equations. Okay, so I have so many answers. So let's try to solve it now. So it says that a baker wants to buy 8 kg of flour and sugar with the budget of rupees 1200. So, and the question asks us that how many kilogram of each can the baker buy if he or they use their entire budget. Okay, so what we do, we'll assign some variable to unknown quantities. So unknown quantities are how many kilogram of sugar or flour we can buy. So let's say X kilogram flour we can buy, and Y kilogram of sugar we can buy with our budget of 1200. So the first line says that a baker wants to buy 8 kg of flour and sugar with the budget of 1200. So that means first of all, the sum of these two quantities, that means X plus Y, should be equal to 8, right? Because he wants to buy 8 kg of sugar or flour. So X kg of flour plus Y kg of sugar should be equal to 8 kg. So that's why this is our first equation. And the second thing says that 150 per kg, I mean the flour cost 150 per kg. So if it will buy X kg of flour, then the cost will be 150 multiplied by X, right? And the sugar cost 100 per kg. So if the baker wants to buy Y kg of sugar, the cost will be 100 multiplied by Y. And what we want to spend all our budget. So that means 150 multiplied by x plus 100 multiplied by y should be equal to 1200. Okay, so now what we have to do, we just have to solve this particular these two equations. So that means x plus y is equals to 8, and 150 of x plus 100 of y is equals to 1200. So first what we'll do, we'll try to simplify this second equation. So we can say that it's simply or else what we can do, we can just calculate y from here, that y is equals to 8 minus x, and substitute the value of y in the second equation. So that will be 150 of x plus 100 of 8 minus x is equals to 1200. Sorry, I have written 12,000. So this is equal to 150 of x plus 800 minus 100 of x is equals to 1200. So that will be equal to 50 of x is equals to 1200 minus 800, that will be 400, right? So that means x is equals to 8. So if the value of x is equals to 8, then what will be the value of y? So y is nothing but 8 minus x. That means 8 minus 8, which is equal to 0. So here the value of y is equals to 0 and value of x is equals to 8. Some people got the answer 6 and 6 and 3 too. So let's try. So 6, first of all, it is not satisfying the first equation, because 6 plus 3 will be 9. So we want to buy 8 kg of, the total weight should be 8 kg of flour and sugar. So if you do not consider the first equation, then 6 plus 3, 6 and 3 might work. But because of this 8 kg, we have a unique solution. Okay. Is there clear? Any doubt in this question? Anything which is not clear, or you want to repeat? Okay, fine. So this such type of basic questions is only there when we talk about problem solving by mathematical approach. Okay, because what happens if you have a complex problem, then the equation might get complex, and for solving complex equations, we don't have that much concept so far. Okay, so now let's move toward the main concept of our lecture, which is nothing but a function. Okay. So I will go through the concept of function very mathematically, that how maths people will define a function, what is a function mean to us. Okay. So this is a particular definition. So in this definition, I hope you guys are familiar with set. So again, I'll repeat, set is nothing but a collection of objects. If you collect something and form, if you collect a well-defined thing, well-defined means if you tell someone about your set, then he should be able to recognize which elements belong to your set or not. So for example, if I tell you that this is the set of natural number, then you guys know what is a natural number and what are the elements which belong to this particular set. So a set is nothing but a well-defined collection of objects. Okay. So now what is a function? So what we do, a function will always be a map from a set to a set. Okay. So suppose we have a set A. Suppose this is your set A and this is your set B. And suppose this is your set B. Then a function is nothing but a map from A to B. So that means it will take the elements of A and map those elements to into this particular set B. But this particular machine or this particular map, so you can take it to be machine also. So for example, your F is your machine and you are taking inputs from this particular set and giving output in this particular set. So you can say that F is a machine or a map which restrict two conditions. So what are those two conditions? So suppose F is a map, you can say map or correspondence or whatever things. It just have to come from the input should come from the set A and output should belong to the set B. Okay. So suppose F is a map from set A to set B in such a way that it satisfies two particular restrictions. So what are the two particular restrictions? That for every element of A, so that means for every A in A. So first restriction is this, that every element of A should be taken as input. You cannot leave an element of A and then say that F is a function. So if this particular F or this particular map wants to become a function, it should satisfy first condition, and that first condition is every element of A should be mapped. So that means for every element of A, there is any unique element of B. And this is the second condition. So first thing is every element of A should be mapped, and the second thing is that this particular element should map to a unique element in B. It cannot map to more than one element if it wants to become a function. Okay, so if a map F from a set A to a set B is said to be a function if for every element of A there is a unique element B in B in such a way that this function F will take A as an input and give us B as an output. So such kind of map, then F is a function. Then F is called a function. Okay, so if you have a map which will take input from a set A and give us an output in a set B, and if this particular map satisfy these two restrictions, so restrictions are, first thing is every element of A should be taken as an input, and the second thing is if an element is mapped to some element in B, then that map should the mapping should be unique. So that means one A can map to only one B. So there should be a unique B in B in such a way that F will take A as an input and give us B as an output. So such kind of maps are known to be function. Okay, so let's try to understand via some examples. So suppose this is your set, and it will set A, and it has 4 elements, and this is your set B, it has 3 elements. If I give you a map like this, so for example, I'll send 1 to A, I'll send 1 to 1 to B, 2 to C, 3 to A, and 4 to A. Suppose this is your map, this is your correspondence. Then is this a function? What you can say by the previous definition? Is this a function?
No, ma'am.
No, ma'am.
No, correct. It is
No.
not a function. Why it is not a function?
Ma'am, because
Because
for
one
input
two
1
times.
there are 2 outputs.
Correct.
because
Because
one
with
input has two outputs.
right, correct. Because this particular one input 1, we have 2 outputs, which is A and B. But what does our definition say? That this uniqueness should be there. This uniqueness is not there in this particular map. So that's why it's not a function. Now suppose I'll give you another mapping. Suppose I'll take the same set and I'll just replace some quantities. So let's make A and B is there. And suppose again we have 1, 2, 3, 4. We have A, B, C. And the map goes like this. Now, is this a function?
No.
No, it won't be a function because this 4 does not have any output. It is not satisfying the word every. Every is not here. Unique is not here. That's why it's not a function. Unique is not here. Okay. So now I think you guys have understood what is the meaning of a function. So if we have a map from a set A to a set B and if satisfy 2 words, every and unique. Every means for every element of A, we have an output and that output should be unique. We cannot have more than one output. So such kind of map or correspondence are known to be functions. Okay. Is there any doubt in function? Who says any doubt so far?
No, ma'am.
So these are this is the basic definition of function. Okay. So now let's understand what is the graph of a function. But before that, we have 2 terminologies. So a domain of a function and codomain and range of a function. So this particular set A is known to be a domain of a function. So for example, if we have a function f from A to B, this is the notation we use to say that we have a function f from a set A to a set B. So that means we are taking inputs from the set A and we are mapping output in this particular set B. So here this set A is known to be the domain of a function, domain of f. And the set B is known to be the codomain of function, codomain of f. Okay, and there is one more set associated to a function that is known to be the range of a function. So range of f. So it is nothing but you have to take all possible outputs. So that means you have to take all f of A in such a way there is an A in it. So if you collect all possible outputs, then that set is known to be your range set of f. Okay, so these are the 3 sets associated to any function. So domain of a function is A, codomain of a function is B, and if you collect all possible outputs, then that collection is known to be the range of f, and it is something like this, that f of a where a belongs to a. Okay. So now what is the graph of a function? So in general, we talk about function from real numbers to real numbers or natural number to something else, right? So in that means if f is a function from a to b, then these a and b are usually the set of numbers. Usually the set of numbers. It could be any number set. So that means natural numbers you can take, integers you can take, any number you can take. So usually A and B will be a set of numbers. And whenever we have set of numbers, we can actually use those numbers to precisely draw something. And how you'll draw? So we have some Cartesian plane, right? So we have this type of plane where this is our x-axis, this is our y-axis, this is our y-axis, and any point over this plane we can find out a coordinate to that particular point. So for example, if I have this point particular m, then what will be the coordinate of m? So the coordinate of m will be some x comma y. Now here we have precise definition for this x and y. So what is x? So x is the length traveled over the x-axis. So it is the length travel over the x-axis. So travel over the x-axis means if you draw a perpendicular from this particular m to your x-axis, then whatever length is here, this length is known to be x. So this is the x coordinate of this particular point m. And what is the y coordinate? So y coordinate is nothing but the length travel over the y-axis. So length travel over the y-axis. So for example, if you draw a perpendicular here over the y-axis, please make
Excuse me, ma'am.
yeah.
Screen is not visible.
Is it not visible to everyone?
It's visible.
Yeah, please check your network.
Visible, ma'am.
Yeah, okay. Thank you. Okay, please check your network. Okay. So what is the coordinate of any point? So we have two coordinates. We have x and y. So x is a distance traveled over the x-axis and y is a distance traveled over the y-axis. So that means if you draw a perpendicular over the x-axis, whatever distance here will get, that is your x coordinate. And if you draw a perpendicular over the y-axis, whatever distance here you will get, those are that is your y coordinate. So what happens whenever we have a function f from a to b, then we can form a coordinate using this function. So what are those coordinates? We'll point out all those points with this particular coordinate. So the x coordinate will be the element a and the y coordinate will be the output with respect to this particular a. Right? So what we'll do, we'll map all those points. Now this is a point for us, right? Point in xy plane. XY plane or coordinate plane, whatever term you want to use, you can use. So that means if we have a function f from a to b, then we can have some points which are denoted by a, which has coordinate a comma f of a, and using this point we can draw actually a picture. So for example, if we have a function f of x is equals to so yeah, in general, a function can be denoted like this. So if the function f of x, y is equals to f of x, this is the basic term or basic notation to denote a function where x is your input and y is your output and f is a function applied over the input x. Okay. So for example, we have a function f of x like simply x plus y. Simply x we can take. So that means if we have a function f of x is equals to x, then how we can draw this particular function? So what will be the graph of this function? Okay, so what we have to do, we have to draw all those points. So let's take it 2x so that we can differentiate between x coordinate and y coordinate. So as I told you, for any function, we have a point like a comma f of a. Right? So here, if you take the input to be a, then what will be your output? Output will be 2a. So that means we have to plot these type of point a comma 2a. So suppose this is your coordinate plane, this is your y-axis, this is your x-axis, and here if we say that this is 1, 2, 3, minus 1 is there, minus 2 is there, minus 3 is there, and so on. So here if we take input to be equal to 1, if you take a to be equal to 1, and suppose this is a function from real number to real number, that means I'm taking domain to be all real numbers. And in general, we talk about the functions from real number to real number. Okay. So if we take a to be equal to 1, the f of a will be equal to 2. So that means first point will be 1 comma 2. So suppose it is somewhere here. The second point will be 2 comma 4, because if you take e to be equal to 2, the y will become 4. So this will be equal to 2 comma 4. And similarly, we'll plot all those points in between them. Okay, so these are all points which satisfy this particular equation. And if you plot all infinitely many points, if you plot every point, then you'll get a line. Okay, so I mean, in this way, we can actually draw a function over a Cartesian plane. So if you have a function from real number to real number, we just plot every point and then draw a line or a curve passing through those points. Okay, so this is the basic definition of a graph of a function, that how we can travel from a expression of a function to a graph of a function. Okay, is that clear? Any doubts so far? Okay. Now let's move to our next topic, which is the straight line.
Ma'am, I have a doubt actually
Yeah.
of the lecture fifth, question number third.
Activity, you have a doubt in activity question?
Yeah, yes, ma'am, yes. In activity question.
Yeah, so we will have a particular session for just solving activity and practice doubt. So
Oh,
I'll
okay.
take your doubt in next session.
But will you please explain the graph for quadratic equations?
Yeah, so quadratic equation also I will cover after the straight line. First I'll cover the straight line and then quadratic equation.
Oh, okay,
Is that
ma'am.
fine to you?
Yeah, yeah, okay, ma'am.
Okay. So let's go to straight lines. So first of all, try to understand the horizontal and vertical lines and what will be the equation of those lines. So again, what do we mean by equation of a line means? We want to find out a particular statement like this, which will tell us what are the points lying over the line. So for example, here, if I give you the line to be equal to y is equals to 2x, right? So suppose this is one expression. This is you have some expression, right? Now, over this expression, how we can say that this particular point will lie over this particular line or not. So for example, if you have a point P with coordinate, suppose 3, 5, right? So can we say P lies over this line? P lies over the line L denoted by this particular equation. Right, so we can say that, okay, since p has coordinate 3, 5, and if it is lying over this particular line, so that means it should satisfy this particular expression. So here 3 is not equals to I mean, here we are simply getting that 5 is not equals to 2 times 3, right? So 5 is not equals to 2 times 3, which is equal to 6. So that means this particular point P is not satisfying this particular expression. So that's why we can say that this point cannot lie over the expression. So here I just want to give you motivation that what are the equations of lines means. So if you have some line, then for that line, you have to find out an expression which will tell us what are those points which can lie over this particular lines or not. Okay, so this is our main motivation. So by equation of line means an expression which tell us which points can lie over the lines or not. So this is the particular meaning of a equation of a line. So if you have an equation of a line, means it will tell us which are those points which are lying over the particular line. So for starting with straight lines, I'll start with two basic equations of lines, which are the horizontal line and vertical line. Okay, so horizontal line means, suppose this is your XY plane. And here, if I draw a line which is actually parallel to the x-axis, right? So this line is actually parallel to x-axis. And suppose it is passing through some y, and let's name that y to be equal to 5. So suppose this is a line which is intersecting y-axis at y is equals to 5. Then what will be the equation of this line? What is the equation? Okay, that is our question we want to answer. That what is the equation for this particular line. So again, what is the equation means? We want to find out a particular expression which will tell us that if we have some point, then using that expression we can tell that that particular point lies over this line or not. So for example, if you take any point over this particular line, so suppose I'll take this particular point M. Okay, so suppose this x-axis has -3 here. Okay, so then what are the coordinate of this particular point M? What are the coordinate of point M?
-3, 5.
3,5.
-3, 5. Correct. Now suppose I'll take another point N here, and suppose this is equal to 2. So then what are the coordinate of point N?
2,5.
2,
2,
5.
and suppose I'll take here somewhere -10 is there, and suppose the point is Q. Then what are the coordinates of point Q?
-10,
-10, 5.
-10, 5. So here over these 3 points, or over any point, if you take over this particular line which is drawn in the green one, then y coordinate is fixed, which is nothing but 5. So that means we can tell that this line, that the equation for this particular line is nothing but y is equals to 5. So if we have any point which satisfy y is equals to 5, that point will obviously, I mean, we can surely tell us that that point will lie over this particular green line. So that's why the equation for this line will become y is equals to 5. Is that clear?
Yes.
That how we can say that the equation, right? So that means this line has equation y is equals to 5. So here there is nothing special about 5. We can replace this 5 with any constant. So suppose this is our constant c, then in place of 5 here we'll get c, in place of 5 we'll get c, in place of 5 we'll get c, and here also the equation will become y is equals to c. Okay, so that means for any horizontal line, the equation of line will be of the form y is equals to c, where c is your y-intercept. Y-intercept means what is the value of y where the line intersecting y-axis. Okay, so that's how we can represent any horizontal line. So for any horizontal line, the equation will be of the form y is equals to c, where c is the y-intercept. Is that clear?
Yes.
Okay. Now this is about horizontal lines. Now what about the vertical line? So we'll use the same concept to find out the equation of a vertical line.
Yes, ma'am.
And then we will go to the general case. Okay. So suppose this is y-axis, x-axis, and here suppose x is equals to 3 is there, and we have a straight vertical line here. Okay, so over this line L also, if we take any point, so suppose I'll take M. So what will be the coordinate here? The coordinate will be coordinates of M 3, 10, right?
3,
X
10.
coordinate is 3 and y coordinate is 10. Similarly, if I take n here, which is suppose it's 2, then the coordinate is 3,
3, 2.
2,2.
Q here will take -5 will be there, so 3, -5. So here also, if you observe that this 3 is fixed, so that means the x coordinate is fixed. So for saying that what is the equation of this line, we can say that the equation of this line is nothing but x is equals to 3, because any point which lie over this particular line should satisfy x is equals to 3. That means that that point's x coordinate should be equal to 3. So that means we can say that the equation of this vertical line is nothing but x is equals to 3. But again, here there is nothing special in 3, so we can replace 3 by any constant. So we can say that x is equals to, we can take c or d, any constant here. Right? So suppose this is x is equals to d. D. You can take d to be any number. That means d to be equal to 1, 2, 3, 4, 3.5, 2.5, whatever things you want to take, you can take. So it means in general, the equation of any vertical line will be equal to x is equals to d type of things. Okay, because if any point which has x coordinate to be equal to d, it will lie over this particular line. So that's all about horizontal line. So suppose you have a horizontal line, then the equation of horizontal line is y is equals to c, where what is this c? C is nothing but y-intercept. So that means what is the value of y where the line is intersecting y-axis. And for a vertical line, we have the equation x is equals to d type, where what is this particular d? This d is the x-intercept. X-intercept means where this particular line intersecting the x-axis. So that's how we can calculate or we can tell what is the equation of horizontal lines and vertical lines. Now let's go to the general form of straight lines. Okay, so for any straight line, for any line, we have a general form, and that standard form or general form is known to be y is equals to mx plus c. Now what is this m here? So m is nothing but the slope of line. So what is slope? So suppose we have this particular line. Suppose this is our line L. So then the slope means what is the tan theta of this angle. So that means if this particular line having the slope is actually given by m is equals to tan theta. So what will be the angle made by the line with x-axis, and if you compute the tan of that, that is known to be the slope of a line. Now how we come across this particular tan theta? So in general, the slope of a line means the change of y upon change of x. So that means how the y is changing with respect to x. So suppose we have two coordinates here. So suppose this is your y. Suppose we have 2 points here. We can take a point to be equal to x2 comma y2, and suppose this point is x1 comma y1. Okay, so now the slope means the change in y ratio with change in x. So what will be the change in y? So we are going from y1 to y2, so the change in y will be y2 minus y1, and upon change in x, so change in x means x2 upon x1. So this is the definition of slope. So a slope is nothing but the change in y upon change in x, that how the y coordinate is changing with respect to x coordinate. So such kind of quantity is known to be a slope. And here, if you draw a right angle triangle over this thing, then by geometry, we know that this angle will be equal to theta because these two lines are parallel. So whenever when two lines are parallel and one line intersect these two lines, so whatever angles will be there, they are corresponding angles. This is general geometry. So since this angle is theta, and if you make a right angle triangle over here, then this angle will be equal to theta. And here, if you calculate the tan theta, then the tan theta is nothing but the same as this y2 minus y1 upon x2 minus x1. Okay, because it's kind of obvious, you can easily calculate why this tan theta is coming. Okay, yeah, it's very easy actually, because we know that this length will be equal to x1, right? This length will be equal to x2. So the length, this particular length will be x2 minus x1, and similarly this particular length will be equal to y2 minus y1. So we know that tan theta is nothing but the y2 minus y1 upon x2 minus x1, this length upon this length. So that's why m is equals to y2 minus y1 upon x2 minus x1, or tan theta. But here one thing we know, that tan 90 degree is not defined. Tan 90 degree means it goes to infinity. So that's why it's not defined. So that's why whenever a line is, okay, so first of all, let's complete this particular concept. So the slope of a line M is actually equal to y2 minus y1 upon x2 minus x1, and which is equal to tan theta. Okay, now here we can say that what happens if this particular denominator will become 0, right? When x2 minus x1 will become 0. So in that case, what happens? Then in that case, our line will become a vertical line, because here only the slope is undefined to us. Okay, because here only the x coordinate will be fixed. So here will be c comma something, here also c comma something. So if you take x2 minus x1, it will become 0. So the slope, so that means the slope is undefined for vertical lines. So this is the note we can say, that the slope is undefined for vertical lines. Okay, because of the same thing, because then if you have a vertical line, then x2 minus x1 will become always 0, and tan theta is also undefined when theta is 90 degree, because here what is the angle? So here theta is 90 degree. That's also the slope is undefined. So if you have a line, then the general equation of line is denoted by y is equals to mx plus c. So what is m here? So m is the slope of a line. So slope of a line means change in y ratio with change in x. So if we have 2 points x1, y1, x2, y2 over our line, then what is change in y? So change in y means y2 minus y1. Change in x means x2 minus x1. So if we take the ratio, then that ratio is defined to be slope. This is the definition. Okay, this is how we are defining the slope. And if we make a right angle triangle over here, we can easily say that this particular m is nothing but equal to tan theta. But here one problem we have, and that problem is what happen if x2 minus x1 is equals to 0. So in that case, we turn our case over the vertical lines, and we say that for a vertical line, a slope is not defined. Okay, but we have an equation of vertical line which is nothing but x is equals to c, which we have just saw. Okay, so that's how the slope is defined. Any doubt in slope of a line?
No, ma'am.
Ma'am,
Yes,
is the slope
Sham.
of the horizontal line is same as the vertical line?
Sorry, what?
Is the slope of the vertical line is the same as the horizontal line?
No, slope of vertical line is not defined. We cannot define a slope related to a vertical line, because we just see over a vertical line, this x2 minus x1 will become 0, and 1090 degrees is not defined. 1090 degrees infinity, so we just simply say it's not defined. But the slope of horizontal line, we can say. What is the slope of horizontal line? So let's try to calculate. Slope of horizontal line.
0.
0.
0, correct. Because what happens, so
0.
suppose this is your horizontal line, then any point will have same y coordinate. So suppose this is y is equals to c, then this point will have y coordinate to be equal to c, this point will have y coordinate to be equal to c. So if you compute m is equals to y2 minus y1 upon x2 minus x1, here you will get simply c minus c, which is equal to 0. So that's why slope of a horizontal line is nothing but 0. So we can use this definition also, or we can simply say that m is equals to since it's not intersecting with x-axis, that's why we cannot use the concept of theta here. But although we can say that here the angle is nothing but 0 degree, because it's somehow parallel to x-axis. So you can simply say that tan 0. So that's why m is equals to 0. This is not that much convincing, because here no angle is forming with x-axis, but this definition you can use to say that the slope is nothing but 0. So that means the slope of horizontal line is 0.
Okay, ma'am.
Okay. Okay, so I have two more results. After that, we can end our session. So the results are related to the perpendicular lines and parallel lines. So suppose we have two lines which are parallel to each other. So suppose this is a line and this is another line. Suppose these are two lines, L1 and L2, and those are parallel to each other. Then how we can say, then what will be the relation in between the slope of these two lines? So suppose L1 has slope M1, L2 line has slope M2, then what is the relation between M1 and M2? So here you observe that again by geometry we can see that, yeah, those are equal actually. So suppose this is angle theta, then by geometry we can simply say that this angle is also equal to theta, because this is a result, standard result. So if you have two straight line, two parallel line, and if a line intersect this parallel line, then all these corresponding angles are actually equal. So we use this particular result to say that if this angle is theta, then this angle is also theta. So that means this M1 is nothing but equal to tan theta, and M2 is also equal to tan theta. So that means M1 is equals to M2. So if we have two parallel lines, then the slope of those two parallel lines is nothing but equal. Okay. Now let's go to the perpendicular line case. So suppose we have one line like this, one line like this, and they will form 90-degree angle here. Now this is your L1 line, this is your L2 line. And suppose the slope related to the line L1 is M1, slope related to the line L2 is M2. Then we want to find out the relation between M1 and M2. So what is M1? So M1 is nothing but tan of theta, right? So suppose this angle is theta. So M1 is tan of theta. Now what is M2? So M2 is, suppose this whole angle is equal to alpha, right? So M2 is tan of alpha, because we have to take the angle between the line and the x-axis. Okay. So but here we can find out a relation between alpha and theta. So here you observe that alpha is nothing but theta plus 90 degree, correct? So here alpha is nothing but theta plus 90 degree. So we'll use this particular equation here. So that means M2 is nothing but tan of theta plus 90 degree. Okay. And if you know the geometry, then it is nothing but minus of cot theta. Minus of cot theta, just by basic trigonometry, right? Because we have 90 degree plus theta. So because of this plus sign, we will have a minus sign. And since we are adding 90 degree, that's why 10 will change into cot. So it's equal to minus of cot theta. But this is same as minus of 1 upon 10 theta, right? So that means M2 is equals to minus of 1 upon 10 theta. But what is 10 theta? 10 theta is nothing but M1. So that means M2 is nothing but minus 1 upon M1. And with the multiplication of their slope, that means M1 into M2 should be equal to minus 1. So this is the relation we get. So if L1 is perpendicular to L2, then the slope M1 into M2 should be equal to minus 1. And the first result we observe that if L1 is parallel to L2, then their slope should be same. Then M1 should be equal to M2. Okay. Is these two facts are clear? Any doubt?
No.
No.
Okay.
No, ma'am.
Now we have seen, yeah. Anything? Okay. So now we have seen plenty of things about the slope, but in that equation we have one more quantity, y is equals to mx plus c. We have this particular c also. So what is this c? So this c is actually the y-intercept of a line. So the c is the y-intercept of line. Y-intercept of line means what is the value of y where this particular line intersecting the y-axis. Because here if you put x is equals to 0, you'll simply get y is equals to c. So x is equals to 0 means we are talking about y-axis. Okay. So the c is nothing but the y-intercept of a line. So this is one equation of a line. So if you have a slope and a y-intercept, you can actually calculate the equation of line. But we can actually replace this slope via some point also and replace this c also with some point. So for example, there is one more formula for line, which is known to be a line passing through 2 points. Okay. So equation of line passing through 2 points. So what are those 2 points? So points are x1, y1 and x2, y2. So using these 2 points, we can actually calculate the slope. Slope is nothing but y2 minus y1 and x2 minus x1 also. So that means using this form also, you can get this particular equation. And the equation is y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. This is the equation of line passing through 2 points. Okay. So that's all about straight lines. Any doubt in straight line? Intercept in so we use intercept regarding to the x-axis. So for example, y-axis, x-axis is there. So we say y-intercept, x-intercept. And intersect means if two lines intersect at some point. So intersect word is basically used if we have two lines and they are intersecting at some point, then we say intersect. Intercept is just y-intercept, x-intercept. It's just terminology. So, okay. So yeah, that's all from my side. I'll upload this PDF over the calendar. There you guys can go and download the PDF if you want the notes of the lecture. Or else, yeah, I'll sure repeat. The last topic means this equation of two lines. Okay, yeah. Just give me a second. Hello.
Yes, ma'am.
Okay. So yeah, so what happened for equation of line, we have two type of equations. So that means you can use any one of them. So one is y is equals to mx plus c. Here we have two quantities. First is m, which is the slope of a line. And second is c, which is the y-intercept. Y-intercept means again the point where the line intersecting the y-axis. So using this equation, and suppose we don't know what is the slope or what is the y-intercept. We just have 2 points, and from those 2 points we want to find out the equation of line, because we know over a graph if you have 2 points, then using these 2 points we can draw only one unique line. Okay, so we can draw a unique line using these 2 points. So that means using these 2 points also we can form the equation of line 2. So what will be that equation? So suppose we have 2 points x1 y1 and x2 y2. So using these 2 points we want to form an equation. So we already have in one equation. To try to use this form to replace m and c with these 2 points x1 y1 and x2 y2. So for m we have a particular nice formula, which is y2 minus y1 upon x2 minus x1. Right? But what about C? How we can change C in this particular form to get an equation in terms of x1, y1, x2, y2. So what we will do, so since these two are the points lying over this particular line, so we'll just put x is equals to x1 and y is equals to y1 and get the value of C. So if we do that, we'll get y1 is equals to m times of x1 and plus C. But m also we know. So what is our m? So y1 is equals to this y2 minus y1 upon x2 minus x1 into x1 plus c. So now what will be the value of c? So c is nothing but y1 minus of y2 minus y1 upon x2 minus x1 multiplied by x1. So now we can replace m with this particular quantity, and we can replace c with this particular quantity and get an equation of line in terms of x1, x2, y1, y2. So what will be the equation now? So y is equals to mx plus c is there. So y is equals to, replace m, so that means y2 minus y1 upon x2 minus x1 of x, and replace c. C is y1 minus of y2 minus y1 upon x2 minus x1 multiplied by x1. Okay, and if you do the calculation, it's similar to y minus y1. This y1 will jump over the left hand side, and here we can take this bracket to be common, which is y2 minus y1 upon x2 minus x1, and then x minus of x1 minus of x1. Okay, x minus of x1. So this is another form of equation used when you have 2 points. Okay, so if you don't have slope or y-intercept, you just have 2 points, and using those 2 points you want to form an equation of line. So then you can use this particular expression, equation of line passing through 2 points. Okay, is that clear? Yeah, so in the next section, I'll start with quadratic equation only. So we'll go in detail with quadratic equations, what are the roots, what are the graphs, and all those things. Yes, Azim.
Ma'am, it was written there that we have to do any attendance. So how will it be done?
I think attendance will get recorded by Gmeet itself, but just wait a second. I'll ask if I have to note down something from my side. Just stay for 5 more minutes and then you guys can leave. Okay.
Please carry on.
Hello, am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah, so you don't have to provide any attendance.